Hello everyone. Today we are going to discuss singly doubly linked list and array memory comparison, or maybe comparison is not a good word here. Maybe which data structures is used how much memory, or which data structure use efficiently memory. So if you are already following my other videos, so we already completed singly linked list implementation and array list implementation, and now I started the working on a doubly linked list. But I think it's a good time to discuss about how these data structures use under the hood memory. So first we can start with an array. Also I will take some help from C++ when I'm sharing with you some information. Yeah, but mostly we implemented in Java and Kotlin. So for example, I have some kind of an object, and maybe in C, so, or maybe Java, any language. So for example, that object is E, and I'm saying okay, create. So it's kind of a pseudocode. I make the array of E object, and E is, for example, have 20 bytes. So in this case, I have 20 bytes. In case of this, in RAM, I will have this. So these are the addresses of our RAM, and once the compiler or JVM anyone start giving us this, it will put this information all together. So most of I will have 20 bytes. I'm assuming this is a whole block is a 20 byte, 20 byte, 20 bytes, and there will be 4. So total we are going to get 100 bytes. So this is an array. The thing is, array is a continuous memory. So one more point, there is no directly comparison between array and singly linked list from this perspective, because array is a continuous memory and linked list is a discontinuous or fragmented memory. So we can't compare from that perspective, and there are benefits from the time complexity perspective in both data structures, but we are only focusing on the efficiency or how they are using. So in case of an object of 20 bytes, I am going to take 100 bytes memory. Now if it's a primitive type in any language, most probably if it's integer, it's a 4 byte. So 5 4s are 20, so that will be 20 bytes. Now if I move towards the singly linked list, in that case what will happen? So if you guys remember, we always have a one data structure which is called node. It may be generic, and then inside it have some kind of a element which is type of T, and then next node, maybe next is enough. So something like this. So pseudocode of this. So we have this node, and in this case, now we need to understand first only one node. Once I will create this node, how much memory we are going to use. So in case of C and C++, most of the time we have a pointer, and as we know, pointer always save the address. Address means memory address, and in case if I have a 4 GB RAM, which is 2 power 32, so 32-bit system, which is 4 byte. So I don't care if in case of C and C++, I'm going to create a pointer and the system is a 32-bit, it means 4 byte for every pointer I'm going to use. In case of a JVM, Java Virtual Machine, I'm not very good with that, but still, as per my understanding, JVM also take care of this, because in Java there is no pointers for the client, like for the end users, the developers only have the references. Under the hood, I think they are using pointers, but for us they expose only the references, and you can do only copy that, but that reference also have that value which we need to save. So in JVM, if it's a 32-bit, I think it will save the object reference, which is a 4 byte if I'm not wrong, and if it's a 64-bit, then it's a 8 byte. And for C and C++, I'm sure if it's a system is a 32-bit, 4 byte we are going to save. So for assume if it's Java, one node, and this T is, for example, is an integer, and integer is an object in Java which is going to take, I think so, 16 bytes. So somehow I have created a same object which I have here, E. So I'm saying, okay, I'm going to create a node of E which is a 20 byte. So in this case, this one node is going to take 20 byte plus this node reference. So if that is Java JVM, and if it's a 8 byte 32-bit, it means 4 byte, and if it's 62-bit, then it's 8 byte. So then there is a variable thing. In case of an array, I think that is independent from the system, like if it's a 62-bit or a 64-bit or 32-bit. But in case of a linked list, as per my knowledge, singly linked list or doubly, that is variable on the basis of a system. So if you assume 20 in the 4-byte system, and I have a one node, now I created a 5 node. So in this case, I have 100 bytes total memory I'm going to use. In this case, I have 100 bytes for 5 nodes plus 5 for the 20. And if it's 8 byte, then 8 5 is 40. So total is 120 bytes. And how it will work in a RAM? So again, I have these addresses 1 2 3 4 5 6 7, and I created first, for example, this is my first, and it's now saying go to the 0x5. So 0x5 is going to back 3, then I'm going here, and it's saying go. So like we are moving in a memory, it's continuous, but it's fragmented or discontinuous. And mostly we make, to understand this easy for ourselves, we make like this. So this is our singly linked list. So now first thing you can easily compare. Here in this case, the same objects 5 and 5, but here I may have 120 bytes, 20 byte extra, and if it's a 64-bit system, then I have a 140 bytes. Now if I move this thing into the doubly linked list node, it means I will say next or previous of T. So now I will have also some kind of a 2 memory addresses. So it means like this. In this case, now what will happen? Our algorithm is going to double this plus. So to make this more clear, I will say for 20 byte for one node, the E value plus, if it's a 32-bit system, for next 4 byte plus for previous 4 byte. I'm not sure in case of a Java, if a pointer is null, is it zero value, or still that is going to refer to some value which is 4 byte, but still assume these are not null. So in this case, I'm going to do 28 byte. So doubly linked list 28 byte, singly linked list 24 byte, and array is 20 byte. So I can write again here. So please remember this, the memory structure. I will not create again. So array, if it's a 20 byte, it's exact 20 byte, there is no overhead. Singly linked list, it depends 4 byte, the system 32-bit or 64-bit, but I'm going with a 32-bit. So 20 plus 4 extra reference in case of a Java. So total will be 24 byte for same information. And in case of a doubly, I have 20 plus 4 plus 4, which is 28 byte. So that is how we are going to use memory. Now there is no comparison, but there are some scenarios where we know it's an overhead, and also we know in most of the cases time complexity of the operations of an array is more faster than the singly and doubly linked list. In some cases, singly and doubly, like deletion is very like fast on a singly or a doubly, but in case of an array, it's expensive operation. Still, it depends from where you are going to delete, start or end. So having said that, we can discuss a little bit more. We can create some scenarios where we can use what. So we need to think, like I'm assuming one scenario. So we have a, because I used to saw a lot of TVs in different places where they have some kind of an advertisement and they are cheap. It look like they are pretty laggy. So for example, I'm writing code for that application which is going to run on that smart TV where they have only RAM for maybe 256 MB, and they have a CPU power which is, we can say it's okay, it can manage. So now if my application, I have a 256 MB RAM and we figure it out, okay, 128 MB is available for our program. I don't care about the remaining 128 MB which is working with the kernel and all other things. So now 128 MB is available for my program, and I know I need to load some kind of a data which is 100 MB. So in 128 MB, I can load 100 MB easily, but there is a catch. If I want to load 100 MB by using array, I have a condition, I need a continuous RAM. And most probably, if you are using JVM or maybe CC++, you will get an exception, or maybe program will be suddenly close with a system error that can't, like the memory is not able to, like that the JVM is not able to assign you that memory. Like you can do a one experiment. If you have a machine, maybe any machine which you are using for the development, go and try to create an Java array with max in dot max, and you will see there will be an exception. It's more like not exception, system error, system exit, program will be exit, and you will figure it out because the problem is that to assign a continuous memory, it's a pretty difficult task for this long memory. In case of an linked list, I don't care if continuous memory is available or not. Yep, only I care if 100 MB is available. I have a overhead. For example, after putting that overhead, I will go until 116 MB. So I can use the singly linked list. Is a very good choice of an the data structure. In this case, what will happen? My program will never do the system exit because I can get that memory. It may be here and there. The problem now is CPU, because in this case now CPU is doing a lot of stuff. If my I'm doing a lot of search. In case of an array, you know, if I have an index, I can directly jump into that. But in case of a singly linked list, I need to do search one by one or move here and there, and which is okay again if our consumer is ready to take that. Like if they are using that cheap device, we need to write some algorithm so our app should not crash, but now there is a trade-off. So in that case, trade-off is there. CPU is going to do a lot of work. Due to that, there will be jank because we are not able to complete things in that time, which is okay, but that will never crash. So in these kind of scenarios, singly linked list can go. Then again in a doubly linked list, so for the doubly linked list, the scenarios are a little bit different because you can go back without. So in case of a single linked list, for example, I want to get the second last object or a node. So if I have a head and tail can't do anything to get the second last. So I need to use a while loop to go one by one. But in case of a doubly linked list, I can directly go, okay, head, tail, give me your previous. So it's a big O of one operation. So now here it depends what kind of application you are going to write. So if your use case is more giving you help, like okay, doubly linked list is really good because you can do these things and you don't need a lot of continuous memory, discontinuous memory, then it's a good application in the use case. So as a summary, we discuss array, singly and doubly linked list. Array is a continuous memory, everyone knows now, and we are getting exact memory of the object. If it's a 20 byte object, so I will get the 20 byte, there is no overhead. In case of a singly linked list, it varies. It depends. If the JVM is supporting 32-bit system, then it's a 4-byte reference of that object, which is kind of a point, not a pointer, sorry, I'm using wrong term, the reference. In case of a C and C++, we are going to get again the, if it's a 32-bit 4-byte, if it's a 64-bit, then it's going to be 8 byte. And the last thing, it's like in case of a JVM, the difference basically, in case of a C++, you can do the pointer arithmetic, plus minus, can go back and next. And in case of a JVM, the reference, Java reference does not support the arithmetic. So hopefully you enjoyed today's discussion. One last bonus thing. So if you guys remember, some days ago I uploaded a video on a singly linked list clear method. So if I have an singly linked list like this, maybe it's like 1000 of nodes and I have head. So once I want to release this, like I want to clear that, I only do head equal to null. And now once GC will run, GC will come here, GC will ask, okay, any object is referencing this object. If not, it will take a whole memory and it's clean. So that is a single linked list. But in case of a doubly linked list, scenario is very different. So I have nodes again. So in case of a doubly linked list, if you are not aware of it, it works like this. So there may be previous and next is null. So I have maybe 1000 nodes and there is a head. So in this case, if I want to do clear, I will say, okay, head equal to null. After doing this, now we have a memory leak, because now GC can't do anything. GC will come here, for example, at this object, and GC will ask, okay, is this object is referenced by anyone else? And this object will say, yes, I am referring to this. GC will say, okay, it's still in use. And the same thing happened everywhere when you have a previous and next. But in a singly linked list, no one is referring, take all. So in this case, once you want to clear one by one. Previous and next null, previous and next null. So it's kind of a big of an operation. We will discuss in a doubly linked list implementation. Only want to share a small bonus. So I hope you enjoyed today's video. See you in our next video. Bye.